Remote sensing affects people in ways they don't even think about. It is used to inform their weather forecasts. It's used to let people know when disasters have happened and where they've happened and where people are going to be affected most. So it's kind of ubiquitous.
Remote sensing brings together technology, science, and environment.
We use satellites, airplanes, or ground-based systems to observe different areas from the Earth, and from there to obtain some information of the Earth's surface.
Remote sensing is a multinational collaboration sharing knowledge and data to understand things like crop sustainability in the face of climate change.
Science and technology capable of acquire data from some objects without contact.
Remote sensing through satellites allows for a large-scale synoptic view of the Earth.
Remote sensing is extremely useful for looking at things with a synoptic view, or at looking at large-scale phenomena like storms and things like that. If you're just observing from the ground, you have a very, very good idea about what's happening at that point. But remote sensing gives you that big picture that you can't get from a single instrument on the ground.
Is the sole or the only monitoring technology able to measure the complete Earth with sufficient spatial resolution and temporal resolution.
Models leave uncertainty, but remote sensing informs those models to make them more accurate.
Without observation, without a clear observation what's happening, you cannot really produce the necessary actions to correct the problem.
The importance of being able to organize our satellite imagery now in a way that allows us to basically drill into a single pixel, let's say 25 by 25 meter resolution, back in time 40 years to look at that piece of land or that coastline. How has it changed over time? So the quality of the processing of the data is also really important.
I think that what we're finding is that remote sensing is becoming more and more relevant to people's lives because we have so many more sensors that are able to image an area.
Remote sensing through satellites provides a large-scale synoptic view of the Earth, which gives 100% coverage, unlike in-situ data.
So it's not always possible for human to visit all the places and to get in-situ information.
For instance, if you want to measure surface moisture, the content of water of the surface, you cannot place sensors everywhere on the planet.
Utilizing remote sensing sensors, you are able to get holistic view of the area, both in spatial and in temporal scale.
When we place sensors on satellites, we are able to observe the globally the Earth, and then we can obtain global information, and then to support the science of climate change.
In the case of remote sensing, you're actually measuring 100% of covering the whole ground.
And with that, you could assess the changes happening, the dynamic changes happening on the Earth's surface.
So the only way is to make from observations from the space to monitor the entire Earth.
GRSS is a community of researchers and practitioners who create tools so geoscientists can understand Earth systems.
And the communities like GRSS allow a platform for knowledge integration.
So this multinational approach is very, very important, and it's becoming important day by day because of the interdisciplinary nature of the subject.
In India, remote sensing gives data for areas where there is no in-situ data.
In India, we have, it's basically the economy is based on agriculture. So it's very useful to have this technology for remote sensing, both in optical and in the microwave domain, to have information of the changes in the agricultural pattern, for mapping different crop types, measuring different biophysical parameters from different crops. One more important aspects of it is also, as we have floods happening in India, and it's a very real situation in India. So it's also useful to map a flooded area and maybe also make some of the models which we can have an early warning systems for mitigating this kind of problems.
In Latin America, the main issue is deforestation of the Amazon.
In the Brazilian context, the issue of deforestation in the Amazon, for example, has become increasingly popular. The world is concerned about the destructive impacts that the largest tropical forest in the world has been suffering year after year, and that can be extrapolated to the world's forest. Therefore, neglecting to monitor natural resources, forest resources, and associated ecosystem service is very dangerous and irresponsible.
Across Europe, there's been an increasing number of heat waves and drought.
So we saw in the last years a very dramatic climatic effects on a local scale. So we had in the Central Europe, we had 2018 to 2020 very dramatic heat waves, long-lasting heat waves with large effects to the society, to agriculture, and so on. And this summer, we had dramatic floods in our area, and people should know where this comes from. We try to make the bridge between these local effects of the climate change, for example, and the global increase of carbon in the atmosphere.
In Africa, they're looking at remote sensing to create data as a service that allows for sustainable decision making.
If you're a farmer in the country, you get a water license provided to you. Government used to have what we called water police, going from farmer to farmer, checking the license that they were given and trying to work out whether they're using the water at the time that they meant to use and they're using the amount of water that they meant to use. Now we use Earth observations as part of the modeling that supports government for making sure that the water licenses are adhered to.
In Australia, the frequency and intensity of bushfires is increasing.
We think that satellite remote sensing is going to be a really big important part of continuing to track and help decision makers understand the magnitude of some of these changes. What's really also really exciting is that the Australian government has now established our own space agency for the last 3 years. And we have just freshly launched the Earth observation roadmap for Australia, which is hopefully going to empower our decision makers, but also our industry to join the global community of Earth observing systems and programs over the next 10 years at least.
Many people say we are in a golden age of remote sensing. We have so many sensors and we have a huge bunch of data.
The research which we carry out today will be important for tomorrow.
We have seen over the decades that this data becomes useful, not one in supporting the decision-making process at the start of a decision being made, but also monitoring policies.
In a world with an ever-changing climate, it's more important now than ever before that geoscientists have state-of-the-art sensors.
I think the future will make it a lot more accessible, easy to use for everybody in terms of Earth observation access to data and information that they can derive from that data.
My research is relevant to people's lives. I think that it's very, very gratifying to be able to do work that might in some way, even if it's a small way, help people in the future.
All what we do can be used to improve the life of people or to save people.
GRSS scientists are creating ever more accurate sensors that are helping geoscientists understand our interactions with our ecosystem better than ever before.